Hello! Welcome and greetings, all of you out there in television land. Oh, yes. This is the last lecture of your undergrad. Oh my gosh. Well, I hope that it has been one heck of an experience. Thank you very much for experiencing their education through the fine institution of McMaster University. Let's make it a good one, eh? Yeah. I'm doing pretty well. The kid needs food, so that's what's going on in the background there. And if you don't mind, I think I'm just gonna close the door.
Yeah, I'm gonna close the door here too. So.
Okay, sorry. Man, when they want food, you know? There's no power on heaven and earth that can stop a newborn from crying except the administration of the thing they're crying about. That is just the way these things work, apparently. Anyway, I'm doing pretty well, feeling pretty positive. Hoping that maybe we'll get a little bit of sunshine today. That would be super nice. Yeah, feeling pretty good about things. Okay. Alright. So, one thing, even though we've only got, like, a very small number of people here at the moment, generally speaking, it's my habit to have an exam review session, at some point during the exam period, reasonably close to the exam itself, usually a couple of days before the exam, and, I was just, it doesn't really work, like, right now, taking, like, a poll of the class. So what I'm going to end up doing is I'm going to use the poll feature on Piazza to take a poll of the class and see where you guys might be interested in having a review session for this class. Like, what day would be good. I want to minimize the number of other exams that the thing's booked over top of. Although it will be, again, through this medium. So the exam review session will be recorded, which means that, you know, if you can't come to the thing in person, then at least you can see it later if you think it's a valuable use of your time. And, you know, spoiler alert, it's probably a valuable use of your time. So yeah, I'll be putting out a poll on Piazza about that at some point, either today or tomorrow, and we can get that scheduled up. But yeah, so yeah, let's continue. Let's continue talking about databases. We're just about through databases. We only really have like one major topic in databases left to go through. So, we're getting into a new topic. A new idea within databases, which is kind of like somewhat more difficult conceptually, but is one of the more powerful uses of relational databases. It's in fact the reason that relational databases are called relational databases. And that is the so-called join operation. So when you have a database, you have multiple tables all in the same database. Very often, you'll be in a situation where you need to cross-reference data between different tables, right? Now, cross-referencing data by hand is about as much fun as the data entry itself. However, since we're in a digital environment, and since we are, you know, we've got things set up such that we are making queries of databases, let's learn how we can cross-reference tables against each other using join operations. So, of course, in order to be able to cross-reference data, we need data that can be cross-referenced. So, I took the liberty in the intervening time between this lecture and the last, i.e., the last 5 minutes before I went before this went live, I entered the data from these two slides into our little working database that we've got. So we now have a select star from customers database, our table. So this is our list of customers. This is our table representing customers. Notice customers have a customer ID, a name, and an address. We also have a table of rentals. The rentals, the rentals table has 4 fields. It has a customer ID, a movie ID, a date the movie was rented, and a date that the movie is due. Obviously, if this were a real example, there would be much more data that you would be tracking, but, this is compact and good enough for a, example for a lecture. So, the problem that we're presented with is that if we select on just the rentals table, we get the customer ID, but not the customer's name or address. And we get the movie ID, but not the movie's name or anything. So you can imagine, if you needed to know what the movie's name was, because in your video store, all of your videos are alphabetized or sorted by genre or something like that, just seeing the movie ID isn't going to be very useful. Naively, we would have to do an extra select operation to look up the customers or the movies, bearing in mind what movie ID we're looking for. So, you would do something like select star from customers where customer ID is equal to 103, for example. And that would give you your information. However, this is like a one-at-a-time process. This is what I mean when I say cross-referencing by hand is a labor-intensive process. So, by using table joins, we can perform these operations simultaneously. Let me see if we have any questions. This is also your last... Oh, well, thank you for attending. I hope that you enjoy it. I hope you've enjoyed all of your classes at this fine institution. I'm particularly concerned with you enjoying my class because, I have the power to make my class more or less enjoyable depending on how people respond to it. Yeah, class of 2021. Woo! There should be some kind of epithet applied to the class of 2021. You started it in meat space, and you ended in cyberspace. Class of 2021. You can quote me on that. So, anyway. So it turns out that with the select command, you can actually select more than one table at once. In the same way that you can specify columns, you can show more than one column with one select operation. You can also select more than one table to view. And this is interesting though, because it doesn't behave the way you might think it would. So customer and rentals. There we go. So this is interesting. That's a lot of data. That is more data by far than is contained in the entire database. So this is interesting. What SQL is doing is it's taking the first element of the customer's database and appending to it the first element of the rentals table. Then it takes the same element of the customer's table, appends the second element of the rentals table. First element of the customer's table, third and final element of the rentals table. Then it goes to the second element of the customer's table, and the pattern repeats itself. So what you in effect get is for every so what you get is essentially a table that doesn't really exist. It's like a temporary table that contains every possible combination of entries from all of the tables that you specify. In fact, if in addition to that we want to throw in the movies table, you can see that it repeats this Same gosh darn process, except now every single possible combination of entries from customers, rentals, and movies is represented in this table. And you can see how that gets to be very, very long very quickly, right? It's like a multiplication, right? It's a multiplicative factor. Another way of thinking about this is in terms of counting theory, right? Like combinatorics. Every possible combination is represented. You can think of it like probabilistically. So, this is fine, but it would be more useful to have some constraints placed on this data so that we can actually view the information that we want to see. So in this particular operation, what we want to view is we want to view both the customer, we want to view the information for the movie and the customer only when those are applicable to a particular rental, right? So essentially what we have to do is we have to exclude every one of these entries where, the movie ID in the rental table does not match the movie ID in the movie table, right? Because it doesn't really, you wouldn't match up movie 101 when 104 is expected, right? But you have to put that clause, you have to put that filter in yourself specifically. So where customer, or let's say rentals dot movie ID is equal to movies dot movie ID. There you go. So you can see that we have narrowed things down significantly. Although everything is, we haven't narrowed things down on the customer side. We have, drastically reduced the number of elements that are being shown, first of all, which is in and of itself useful. But we have, basically, what's going on in the rentals table is the only rental ID that exists, or the only movie ID in the rentals table that corresponds to an actual existing movie in the movies database is movie number 104, Field of Dreams. And that's why you see here the only movie that's being displayed here is Field of Dreams, because that's the only one with a movie ID that matches. So you'll notice that since there's no match for movie ID, what was it? Yeah, 5022, because there's no movie that matches that, the movie ID in the rental table matching the movie ID in the movie table is a condition that will never occur, which means that entry, that generated entry will be excluded, right? Also, one more thing to note, you access the fields of a table in the same way that you access the attributes of a class using dot syntax. Dot syntax! So, let us further refine our search. And rentals dot customer ID is equal to customers dot customer ID. There we go. So once we have done that, customer ID 103 exists inside of, customer ID 103 is the only one that exists. So in fact, the only entry for which we have corresponding customer data and movie data is when this guy, customer 103, Randy Wolf, rented Field of Dreams on the 12th of March. So that's how you can pick out particular data. And of course, if you're only interested in specific data inside of that, you can always narrow the search fields as well. So select customer.name and movie customers.name and movies.title. Add that clause in there as well, and you can see you can narrow things down and display only that information which is pertinent. So yeah, that's how a join works, basically. Is there any way to format the table so that the columns line up with each other? Not really in a command line interface. However, if you are required to use databasing for anything other than this class, i.e., if you're going to be using it in your career or, you know, a workplace environment or what have you, it is entirely, like, you are absolutely not going to be using SQLite. What you'll be using is some sort of more built-up database management software, most probably. You know, you'd be using something like Microsoft Access or MyPHP server or some kind of one of the other ones on the list, right? Those guys have better and nicer ways to format the data that, you know, you can look through and you can see what type they are and the columns line up and all kinds of nice stuff like that. But because this is like the most basic of basic interfaces, you are not afforded those kinds of luxuries. Or maybe it has an option for it, but I'm not aware of what that option is. Google is always your best friend. So yeah, that's how you perform a join. Are there any questions about joins or that process? Can I get a thumbs up from the audience? Yes. Best of luck in grad school or whatever you're doing next. Yes! Yeah, of you guys who are graduating, anybody going to grad school? Anybody, you know, would you like to take a moment? You don't have to, it's totally okay, but would you like to take a moment and, you know, and state what your plans for the future are? I'm sure that would be of much interest to any first years who are in the crowd, you know? This can be an opportunity for peer mentorship in a very conciliatory fashion. We got thumbs up. Good. See, I'm trying to encourage the social aspect that's lacking from online school. Cool. Everybody's got thumbs up. Lots of thumbs in the house. Yeah, so the result is as if we had a single table with rows from each table joined together when they match on the customer ID field, as demonstrated. This is also called a join or inner join operation. Yeah, so, and this has already been demonstrated. So that's good. So, having talked about joins, we can we've gotten to the point where we now mop up with some basic operations which are not difficult to understand, but we haven't talked about yet so far, so we should talk about them before we get, you know, let's say these are things that are absolutely necessary for you to know to have had a reasonably complete treatment of SQL, but they're not, like, we're going to learn how to delete things, basically. Delete and change. Ah, cool. Starting a full-time job. Congratulations for having actually gotten one. That's pretty impressive these days. So congratulations on your job. Yeah, into EPI. So this comp sci course will be incredibly useful. Very cool. I don't know what EPI stands for. Trying to think what that could stand for. I don't know. Grad school for Vincent? Yes! Grad school, grad school, grad school. Awesome. See, guys, it is possible. People do get into grad school. So, good. Awesome. I imagine a lot of people, like, my general impression of this course is that a lot of people who are in their 4th year who take this course are taking it because they kind of come to the realization that the ability to program is a thing that's really, really useful when you hit grad school. Like, especially within... Oh, epidemiology! Ah, there we go. Cool. Ah. Yeah, your skills would be in great demand at this particular point in history if you're studying epidemiology, eh? Yeah. Yeah, congratulations to our graduating class. You guys are going to take the world by storm. I can feel it. But yeah, a lot of people who get sort of within the vicinity of grad school are like, wow, it might actually be really useful to be able to program because, you know, a great number of the types of like research operations that you do these days are going to require you to know some degree of programming. This has been a thing that's been sort of increasingly true as time has been wearing on, as the decades have been wearing on since computers have been introduced into the whole system. Where I'm comfortable saying at this point in time that if you're doing a graduate work in the physical sciences, you should assume that programming is going to be a useful skill at some point. It's actually kind of interesting because, like, in you know, people who are doing graduate work are always looking for, you know, applications that haven't been tried yet, right? You're always looking to try some new methodology or some new thing and apply that to some existing, you know, methodology, right? You're trying to keep things on the cutting edge. And, you know, it's my general impression that there's still room within the physical sciences for just, you know, straight digitization of existing processes, you know? But, or at the very least, you know, big data applications are a thing that you probably, you know, data collection and data processing are increasingly becoming useful things to know how to do, you know? Yeah. Any interest in data analysis is going to require Python. Python is interesting because it's, like, now the, I believe it's the preferred language for artificial intelligence as well. Sort of, well, artificial intelligence is kind of a nebulous concept, but all right, let me finish these slides. Then we'll talk about these things, because that's the next topic. So, anyway, update operation. You may have noticed that it seems somewhat difficult to be able to change data once it's been entered. There's a specific command for it. You use update. Update, you have to specify a table. So movies. Let me see the movies table first. Select star from movies. So, update movies. Set genre equal to horror. So change the genre to horror. Where title is equal to Monsters, Inc. There. And if we view this again, you'll notice that Monsters, Inc.'s genre field has been changed to horror. So there's a very, very important proviso here. This update operation absolutely requires the where filtering statement, or else this update will be applied to every single entry. And effectively, you'll blow out every piece of useful information that existed. It will all be overwritten by this new this new information that you're overriding things with. So always, always, always include a where statement when you do that. Otherwise, you'll destroy all of the data in your database. Delete. You can delete rows from tables as well. Once again, don't forget the where clause, because that's how you prevent yourself from deleting the entire table. So if you just do delete from movies, that'll delete everything in the table. And in SQLite, there's no undo function. And if you want to do super, super scary stuff, you can drop a table entirely. This was alluded to when we were talking about SQL injection attacks. Dropping a table means deleting a table in its entirety, including everything inside of it. There is no undo, so be careful with these operations. These operations are kind of operating inside of the Linux mindset rather than the Windows mindset. Windows as an operating system tries to the degree possible to insulate the user from their own stupidity. It's like, are you sure you want to delete that? Are you sure you want to run this program? I'm not sure I trust the source. It's like, Windows is like the helicopter parent of operating systems. Linux, on the other hand, Linux is perfectly happy to allow you to delete your operating system and everything in it. Like you can wipe pretty much everything in your file system with 8 characters in the wrong place at the wrong time in the command prompt. I'll show you what those characters look like, actually. If you do rm r star, that rm is the delete command, delete file. R means recursive, so it goes down into file folders, deletes everything in the file folders, and then works its way back up. And star means apply this to all files. If you use this series of characters, 1, 2, 3, 4, 5, 6, 7 characters, if you put those 7 characters in at the root of your file system, assuming that you've given yourself sudoing privilege, so you need super user privilege to be able to do that to the entire operating system, but it's not difficult to get sudo privilege. All you have to do is sudo rm r star and then enter whatever your super user password is. Then you can easily just delete your entire everything. Boom, just like that. No undo. So Linux does not, to the same degree, insulate you from your own stupidity. You can very much screw everything up with a person who doesn't know what they're doing or is malicious can easily destroy their computer. So yeah, and but the thing, so you're kind of like, well, why would you ever want an operating system that would allow you to destroy it? And the answer to that is because with great power comes great responsibility, but with great responsibility comes great power, right? That's the interesting converse to the Spider-Man, the famous Spider-Man phrase that they never tell you about. With great power comes great responsibility, but with great responsibility comes great power. Because you have that level, because you're given that level of responsibility for managing your own affairs, you can do some really powerful things with Linux if you know what you're doing. And any of my Linux bros out there will know exactly what I'm talking about. So yeah, that's delete. Let's see. I already talked about this. This is the dangers of using string insertion on queries that are entered through Python. So we already talked about that. The problem with that is that that makes you vulnerable to SQL injection attacks, which we already talked about. So we are done with databases. Ta-da! Cool. So moving on to topic 12. We're not going to have like anything approximating any time to go through all of this, considering it's 20 minutes left of lecture time in this whole entire dang semester. So if you want to go through this material, unfortunately, the best I can do is say I have lectured on this topic in the past. If you look up my lectures from 1MD3 for this course from a previous semester, you'll find lectures on machine learning, and please feel free to go through those at your leisure. It's not going to be on the exam, so don't worry. Obviously, it's not going to be on the exam because we haven't covered it, and I'm telling you to go watch videos rather than actually get a live lecture. And I know that's the standard to which some courses have been holding you guys this year, but that's not how we do things in my republic. So, anyway, so machine learning, you don't have to worry about that being on the exam. It's kind of strictly if you're interested in the topic. Now, you are likely interested in the topic because machine learning is a very sexy area of research right now. Lots and lots and lots of different research applications are opening up for applications of machine learning. Machine learning is not artificial intelligence, in the opinion of this guy who has just about got a PhD in software engineering, so you can take that for what that's worth. Artificial intelligence is a very interesting field within computing, because anything that it ever generates which is useful is then spun off into its own entire field. And it sort of leaves, over time, artificial intelligence is left impoverished because all of its children grow up and move out. And that leaves it with an empty nest every time. A good example of that is actually voice recognition research. Voice recognition was originally very much considered a thing under artificial intelligence, but sort of as it actually became good, it became its own kind of separate area of research and study, and the AI guys sort of moved on to different things. So, machine learning. What is machine learning? Essentially, it's statistical analysis. Statistical analysis over large data sets. The idea is, in very, very broad strokes, you've got two main types of machine learning. You've got supervised learning, and you've got unsupervised learning. Both of these are instances where you're trying to come up with, the computer itself is trying to generate a model that has the ability to predict future data points. So one of the most basic ways of being able to do this that you guys are already familiar with is linear regression, right? So linear regression is a way of taking data and trying to forecast where that data is going to be in the future. Obviously, this is operating over numerical data, but this is machine learning when you ask a computer to do a regression for you. However, that's, machine learning is much larger than just linear regression. You also have things like clustering analyses. So the idea with a clustering analysis is you have groups of things. You have data points that are you sort of plot data points in space, and you want to be able to detect clusters of these data points, because these clusters of data points often correspond to things like physical properties. So there's an example in this set of slides of various attributes of animals, right? So we've got various animals here with various attributes listed. One way of being able to tell, like, for example, are these things reptiles or not, or are we talking about a snake or not, is by sort of plotting all of these things and coming up with a clustering analysis. Because in theory, all of the snakes will share similar features because all snakes share similar features. That's what makes them snakes, right? So, you know, you can perform a clustering analysis to get all of the things that that look similar, and if a certain number of those have been labeled as snakes, because again, like one of the things with what machine learning is, and this is kind of the difference between supervised learning and unsupervised learning. With supervised learning, some kind of exterior entity will have labeled the data according to the categories that are interesting to be discerned from it. So, in this data set has been labeled. Each entry in this data set has been labeled as to whether it's a reptile or not, right? So, presumably, all of the reptiles will be clustered because they all share a certain, similar set of features. If inside of a particular cluster you have a predominance of one label or another, you can then draw the inference that that label is applicable to that cluster. So when you analyze additional data points that are not labeled as to whether or not they're a reptile, if they are sort of within the clusters as they have been established by the machine learning process, you can make a prediction as to whether that new data point is or is not, or should or should not have some particular label based on its clustering. So that's a lot of words I just said, but yeah. So that's the rough idea. With and there are various mathematical transformations that you can perform to try to in order to perform clustering analysis, the thing that is required is the ability to be able to tell the distance between different data points. Once you can tell the distance between data points, it's relative, you can just apply mathematical methods. Of course, when you're talking about data that looks like this, it may not be obvious what distance looks like as a concept, right? So you have this idea of taxicab metric or Minkowski distance. So the idea is, say you go through this guy, replace true with 1, false with 0, and you normalize number of legs so that it is also between a 0 and 1 range. So you divide by the maximal element inside of the legs column, right? You can then perform Minkowski distance calculations to be able to determine the distance between different elements inside of the dataset. So, for example, there's no distance between cobra and rattlesnake because they, because they have all of the same attributes here. However, if you look at boa constrictors, the distance, the Minkowski distance between the rattlesnake and the boa constrictor will be 2, because you have a difference in poisonousness and egg laying. So, this constitutes a distance of 1. This constitutes a distance of 1. So the distance between the Minkowski distance between rattlesnake and boa constrictor would therefore be 2, because all you do is you sum all of the differences of all of the various parameters without performing the usual step that we would do in Euclidean geometry of squaring those distances and then taking the square root, which is the application once again of the Pythagorean theorem. You just strictly take the differences themselves and sum them, and that allows you to have a way of judging the distance between different data points, which enables you to perform a clustering analysis. So that's how clustering works. Classification is in general. So, and again, the purpose of doing these clusters is to be able to accurately label data. So, like, these CAPTCHAs that they're doing, right? You know how they'll present you with like 9 different photos and you have to select each one that has a stop sign in it? You know what you're actually doing there? You're training artificial intelligence for self-driving cars. What you're doing is you are generating a data set, which is being used to train machine learning algorithms so that they can pick out a stop sign from an image, which is a very important thing that you would want a self-driving car to be able to do, assuming it's interacting dynamically with a physical environment, and assuming you haven't set up like this vast, electronic infrastructure that's guiding the self-driving cars, which, is an alternative way of setting that up, but, it would take, several decades to be able to roll that type of infrastructure out, sort of continent-wide, assuming that you had the money and political will to do so. It's kind of like the charging station problem. So yeah, let's see. Okay, good question. So, given this chart, why is boa constrictor deemed a reptile by the computer when salmon is not? So, that's because, with this data, this final column is not generated by the computer. This final column is assigned to these data points by some external factor, usually a human being. So this is the idea of training data, right? So if you have the data points and you perform a clustering analysis over them, all you have is clusters, right? In order for those clusters to be correctly interpreted with different labels, the computer needs to be trained on those labels. So generally speaking, the procedure for this is that you have a set of training data and you have a set of testing data. So the training data has labels and the testing data does not have labels. And the test of the machine learning system is to see if the system, once trained with the training data, can accurately predict the labels of the testing data. I misspoke, actually. It's not that the testing data doesn't have labels, it's that the labels of the testing data are not used by the machine learning process. They're used after the fact to test whether the machine learning process worked or not. Right? So, if you go through this set of slides, this process is actually demonstrated a couple of times. There's a whole process for taking your data, splitting it into your testing and your training groups, and then, the testing group is used to train the machine learning algorithm, and then you can measure how accurate your machine learning algorithm is using the testing data. And in general, because these are statistical problems, right? All machine learning is just applications of statistics over large data sets. Because this is statistical analysis, the more data points you have, the better your analysis will be. Because that is the law of statistics. The more data points you have, the more accurate your predictions will be. So, although, of course, the manner in which the data was collected is not inconsequential. Is not inconsequential. You have to try to make sure that your data isn't biased. In the same way, you want to make sure that the data that you're feeding into a machine learning apparatus isn't biased. But anyway, so we've been talking a lot about supervised learning. Where you have training data, that's called supervised learning. I want to touch very briefly on unsupervised learning. The idea with unsupervised learning is that you're giving the computer input that doesn't have labels, and the goal is that the computer identifies some structure or pattern in the data and is not it's not confining itself to reproducing labels as assigned by human beings. It's kind of it's trying to come up with some way, some new computer way of doing things. normally, in order to normally the way that these sorts of things, like, I'd like to talk about genetic algorithms now for just a moment. So sometimes what you want is you want the computer to become progressively better at performing some sort of task. So there's this YouTube channel that I really like, which I believe is called Code Bullet, and this guy makes little video games, like, you know, like an Infinite Runner video game or something like that, and trains AIs to play those games. And it's very, very cool and informative, the process. Let me see if I can find it, actually. YouTube. Code Bullet, come on. But that's like that's an example of unsupervised learning. Rather than Code Bullet. I think this is it. Yes! Yeah, this guy. So, I highly recommend this channel. If you're interested in applications of artificial intelligence, because, you know, because it's a video game, it's very sort of intuitive, if that makes sense. You can understand the problem very easily. Like, understanding the problem of playing Tetris, that's, you know, that's something you can intuitively understand. So watching a guy make an AI for Tetris is really interesting. But, so, you know, it's not like the computer is just being asked to generate a model with no goal. If you don't have a goal, then there's no point, right? Life needs goals, so AI needs goals as well. In this particular, like, in these cases, the cases of the types of things that this guy does, his goal is implicit in the game structure that he's making the AI for. So you can judge the fitness. One way to think of it is in Darwinian terms. You can judge the fitness of the AI by how well it plays the game, right? And so therefore, you can generate a bunch of variations on an artificial intelligence, you know, and that often just means like tweaking variables within a structure, although it sometimes means structural things. You can generate all of these different, you know, differently configured artificial intelligence algorithms, have them play the game, and then, you know, select the best one of that round, use that as the basis for the next generation. And that type, like, that's another type of artificial intelligence. I'm not sure like you would necessarily call it machine learning. It's a type of machine learning. But essentially, you know, the data points it's collecting are not so much like large databases of statistical data or large databases of like labeled data, but runs through of, you know, the Tetris game, right? That would be the data upon which you've based your algorithm. But yeah, I highly recommend this this channel if you're interested at all in artificial intelligence. You know, doing it in the context of games makes it very understandable. Just an idiot with a computer science degree trying his best. Aren't we all? Okay, ba-ba. Oh my god, did my camera and mic just go? Jeez, man. I guess that's the way. That's the way things go around here. Jeez. Okay. There we go. So, any questions about anything? Ask me anything. Because it is now 11:20. Congratulations, you have made it through the lecture component of Computer Science 1MD3. I hope that I hope that everybody here has had a interesting and wonderful journey through the... I was about to say something nasty. Through the wonderful paradise that is computer science and the learning thereof. Ooh, he has a website? That's cool. I'll have to check that out sometime. Tips for the exam. You know, I always say to my students that the best preparation for the exam is the course. You know, if you have been if you've been keeping up with the course material, if you've been asking questions when you've had questions, if you've been doing okay on the assignments, if you've been doing okay on the tests, then it's entirely probable that you'll do fine on the exam. The exam is going to be more challenging than the tests were, but it's kind of like challenging but still achievable. That's always what I shoot for. But yeah, definitely review the practice material, like the practice exam that's been posted to Avenue. That's a great place to start. Yeah. I always think it's obvious what the major topics in the course are, but just in case it's not obvious to you, you know, you can expect something about recursion. You can certainly expect something about objects. You can expect some file I/O. You can expect maybe a little bit of databasing, and, you know, probably something about floating point numbers. Definitely you'll need to be able to use exception handling, you know. All of those types of things. Those are major topics. So yeah. I hope that I run my course in a way that it's not a mystery what the exam's going to have on it, but yeah, thank you everybody for attending. This has been good. You guys are awesome. So, question from Jamie. How would you recommend learning after this course? I've heard project-based learning is the way to go. Yes, that's what I always recommend with Python or any other language, really. So it really depends. It really depends on like what your current level of skill is. But you really, really can't understate the power of a good project, right? It's tricky sometimes to choose a good project, though, because if you choose one that it's like, oh, this would be a great resume project, but it's not something I'm really interested in, you won't be able to muster the motivation to be able to do it unless it's something you're interested in. So my recommendation, find something that interests you and do a project about that. Like, for me, like, I love video games. You may have noticed. So for me, when I do a little side project, it's always like a video game. And, you know, lately the video game side projects I've been making have been good enough for commercial release. So that's like that. If you can manage to take a project all the way to commercial release, that's like the 100% gold standard, because you will learn so much from actually releasing software. People will tell you what the problems with your software are. It's like, sometimes it's very difficult to get good feedback. That's the other thing about code projects, is once you've done it, absolutely get people to try it. Unless people try it who are other than you, it's like, you're not going to learn as much. So, A, take on a project. B, show it to people. C, show it to people who know what they're talking about. And D, see if you can work it up into something commercially viable. When you are working on a project for commercial viability, the absolute number one thing that you want to keep in mind is keeping the scope small enough that the project can actually be finished. Number one mistake that people make is taking on a huge project that's way too big for them to ever be able to finish on their own or in less than 20 years. That's especially in game development. it is far, 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 far better to do 10 tiny projects than one supermassive one. Small projects that can be accomplished or failed at quickly, right? It's like rapid failure. You do the most learning on a project within the first 4 hours of starting it. So the more projects you start, the more you're learning about it. Like, obviously you don't want to have like 100 projects that you never finished, but even then, that's better than, in my opinion, from having like 3 projects that you still didn't finish, but you completely blew the scope out of, so you're never gonna actually finish them. But yeah, project. Your project, a good project is worth more to any employer than any number of CS courses. Absolutely. Any good course resources for learning another better programming language? Ha! Yeah, watch my lectures on C, from the previous semester. That would be a good one. It's really, when it comes to programming language, I think it's a mistake to choose the language and then choose the project. I think you should choose the project and then choose a language which is good for that project. Always view programming languages as tools for solving problems. You wouldn't use a hammer when a wrench is needed, right? So you wouldn't use like C when it's a C# situation, right? So allow, although, it's also good to keep in mind that, learning certain languages is a good resume thing, right? Like, if your goal is to learn C++, then that's a good goal. But if your goal is to have a programming project to demonstrate to an employer that you can program, allow the project to dictate some of these things, right? Good. Thank you. Thank you, guys. Thank you. Thank you for enjoying this class. I always hope that people enjoy my classes. Genuinely one of your favorite classes. Oh, stop. If you really enjoyed this class, I would appreciate it if you left me a good review on the course evaluations, which I believe are closing tomorrow. So, not that I'm plugging for course evaluations or anything, but for a person who is in a sessional position, my continued employment is to some degree contingent on me getting good reviews. So, yeah. Thanks, everyone. This has been a great semester. We'll get that survey up on Piazza to see when we might have the review session. But yeah, go on, get out of here, get out here, go forth into life, and shine with your new knowledge of programming and your new skills in mathematics acquired through your educational process. The world is a complicated and vast set of problems, and you are now slightly better equipped for handling that vast and intimidating set of problems. Go in peace. Go in math. Have fun. That's the most important thing. Always have fun. Anyway, take her easy, folks. See you during the review session. Oh my god, did my camera just go again? Jeez, man. Ha! It's just not my day. You know what? I'm not even gonna fix it. That's a good thing to end on. I'll see you guys. Take her easy.